Okay, let's jump off into Sir Campbell here. Are you thinking it started at the roof, not the parking deck? I responded to him that no, it's still the parking deck, but the building, what we see in the video, the roof is what goes first, not the buckling of the column. And I think that's simply, think of a shake table. Now I'm trying to find some shake table evidence on this. I've got a couple engineers helping me out that actually make shake tables. We're working on trying to find a model where I can do this. The problem is it's a concrete. Most shake tables are dealing with wood or with steel members. Not many of them have anything to do with concrete. And when they do have something to do with concrete, they're reinforced with some bracing, some shear bracing. So I'm trying to find one that's without a shear bracing. Of course, you can go to California and look at the many collapsed buildings with the shaking that took place, that takes place there, and they've had to retrofit many repairs. So you need look no further than California if you want to understand that you don't get to shake the ground for free on a structure that's not braced to take the shake. All right, so again, it's I'm still at the floor. Let's dive into that just for a moment. So the opportunity was there in 2021, as reported by the Miami Herald, I believe, in there. These two images, I believe they belong to the Miami Herald. Oh, well, don't belong to them, but that's their narrative. These are the dates, June 2021 and April. So this was the month of the failure. They sent out the association. I know we like to blame the association for lack of care, lack of repairs, etc. But on the other hand, you remember, I don't throw out the baby with the bathwater. On the other hand, they had this report, and when this showed up in June of 2021, they did not just sit on it. They asked for an expert to come out. As I understand it, they sent the company sent a female engineer out, and I do say female, identifying that because I'll say male also. So you can go into that as you want. Obviously, I beat up on male engineers, Denny Pate, for example. So it's just to identify gender, and gender does count in this field. And don't get me confused. Denny Pate would be if you're looking at how you would do it, it would be alpha in personality wise. He ran that room. Of all the engineers, he ran it, and none of them stopped him. All right, all the contractors, none of them stopped him. So he was the alpha male in there, the alpha bear, wolf, tiger that told them that you're going to do this, proceed, and that ultimately 8 people died, and then the alpha disappeared. So it does matter. In engineering, it's quite often like that. People won't speak up. They're scared, shy. A lot of shy people in engineering don't have the balls to stand behind what they're thinking, or the balls to say, damn, I screwed up. I had some solid thinking there, I thought. But now that you've revealed that to me, I see now that, no, my thinking was defective. It was defective. And let me think about why it's defective. Yeah, because you showed me here that there was actually let's just make up something. A guy they were doing plywood up there at the top floor, and he stockpiled all his material plywood on top of here, and this caused this to rotate at the deck only, not at the deck rotation, but at the deck only, that this fell over. A backhoe came in and hit it, and they fixed the gate. A vehicle backed up, smashed the other side of the wall, pushing the soil that pushed this over, and it's not revealed to us till, and then they fixed the gate already. Interesting. One of the followers here before they got banned, he was one of the people that literally fixed this gate between the two openings here. You can go back into my videos and possibly find them. We talked, we discussed about what he thought about the repair and etc. That's in that video. no need to go into it now because besides stating that, so literally in this image above, the April 2020 image above, we have a crack showing right here. Can you see the crack? You guys know the way, anyone who watches my content knows the way I present. I want it to be memorable, so I do the things that make you say, what the hell is he talking about? I don't see the crack. Okay, I agree. That's April 2020. It was not present. We have this long lateral crack as it relates to the deck, or the wall itself. It's lateral. Vertical would be this way, and it's in plane, and mostly in plane. I think it drifts up there. Now it's now present, and it's also shifted west to east. West being the one end of the building, east being the ocean side. I get that right? East being the ocean side. So it's now shifted. This is more easterly. This section here is more easterly, or this section is more westerly, the bottom. This depends on how the shift took place, this rotation. I'm gonna zoom in. Give me a moment. So let's just zoom in on 2020, April of, it looks like the best I can do almost. Okay, here we go. April 2020. We're in there pretty tight. We see that the trash can pretty much stays where it is. This is the rust stains from the steel of this trash can. So they shifted around a bit, but there's the rust stains going into it's like dyeing the concrete surface. Here it just looks, whatever it may look like, kind of whatever, shoddy like. There is where the mortar's still together, and this is like an elastomeric, I think, coating, which is what you use in things like down there at the beach. It will allow breathability and stretch, elongation with the temperature ranges. Looking at the floor, I'm trying to see if there's any separation. I don't see the cracks presented here, across the top, anywhere here. I just don't see them. Looking in the background, I just don't see them. I do see that little, this thing here, but it looks like that was done. That they painted over it or they plastered over it, because you could see the hickey, if you will, like that. That's kind of inversed, like that. This section here. So it looks like the different craftsmanship, could be the photographic imagery, but this appears to be flat to this side, appears to be flat stuccoed, if you will, and then painted over. But this one is not. So we got multiple events going on here, or you have one contractor that sucks one day and then doesn't suck the next. I don't recall what this is down here. I don't recall what that is. If you take note of that. Okay. Now let's slide down to it's April. This is April of 2020. Fast forward to June. We see the rust stains. Let's get some scale to that. So here's the outer edge of the rust stain. And so now we can see the balance of that. The balance would be all of this. And we can see behind it now. So let's take a look what we could see behind it. So behind it, let's remember where that is, right? Now let's go ahead and zoom in. Behind it, looking at that only, I observe through this photograph, this seems pretty, ish like that. This is also, seems like it's leaning out. This seems like it's leaning out. Now let's think about the photograph and the photographer. If this is the full photograph only, we have to think that this is the center, the least amount of distortion. As you get to the outside, this is the most distortion, okay? Most distortion. Considering that this is not a cropped image. So this would be the least amount of distortion in here, and as you go outwards, you're going to get more distortion. Now let's see what that would look like literally or something we know what we can look at. And let's look at the chairs in the background, and the shapes. Still, they identify as a chair. The distortion is pretty limited. It's pretty great on the trash can lid, considering these aren't bent trash cans. We start bent lids. We start seeing now that considering these are probably 90s, you now see the distortion leans out to your left. Okay, so now I'm going to put some of that distortion back over here. If I had the real scaling, I would just grab this line, move it over, and see if it lined up with there to see where this distortion is equal. I don't have the luxury of doing that with what I'm using to communicate with you at this time, but NIST does, and some of you do also. So you can do that yourself on the distortion. Going back to, zooming back out, again, working from the center, I would consider this the least amount of distortion, and as you go further out. Nevertheless, the gap is huge here. That looks like elastomeric type of painting material. The fracture is thereabouts there. Now this is what we're presented as that the engineer saw. So it could be a wrong narrative. You know you can't trust news networks. So the most news networks. I consider myself a news station of a type. But I tell you, don't trust me, verify. So as we go across here, as you look right here, this side appears to be lower than this side. This puts our dip here. Looking into it, seeing ghost, if you will, this looks like it's negative, like it's going back down. And so that would be like that. It looks like it's actually down. So if I would do it this way, I would say rotating downwards. And I would put it right here to get me my downwards and opening here. That would get this rotation. So we have our full wall rotating. I'll get you a little bit more. So when this person saw this, as I understand it was reported, shrubs were the blame for this. Which, someone needed to find a new job, not evaluating structures IMO on that one. Let's move on. You have that now. So this shows the deck deflection. You have that in your mind. The deck's deflecting. There's a column thereabouts here. It's below the deck. It's there about right there. So when this deck goes down, you actually see this section on the ground. This bond beam section, this top part on the section laying here. I think it has a little thin layer there, and then it goes something like that. This might be up here. I'm just trying to use my memory. Here we have the one beam that's out of bounds, out of the planter box. It's the planter box there. That's for your noteworthy. For your notes. Here's that beam I talk about right here, the bond beam. It goes back there like that, and over here like that. There's the column I mentioned that it was standing over. Remember, we're dealing with distortion of the lens, so don't think these are leaning away. They are plumb. And as you distort going away, as you can see, this appears to be going that way, and this appears to be going that way. So the distortion does not parallel right and left. It goes opposite. To the right, it will lean to the right. To the left of center line, it will lean to the left. Now, if you guys want to invest in some software, you can get hold of me, and I'll tell you what software will help correct these two. It corrects it pretty damn good. I mean, it's pretty awesome. While we're here, there's a plant. Okay, that didn't work out like I wanted. Okay, let's go with that. It's actually what I was looking for. So there's that. And so I was wrong. Remember I put it at the bottom? There it was at the top. So like a broken clock, I am right twice a day. All right, so this wasn't one of them. I was right when I said I might be wrong. It might be on the top. Okay, so there's the end of the planter box, and there's the planter box part. Now I did a whole video on this piece here. You can find it. You can go through all that. Don't really have it marked off like that. Looking at there's the column. It's directly underneath of that wall system. That wall system has that fracture in it. That fracture was because this deck was settling, and it already that fracture was already exhibiting itself because of this rigid column underneath was not being subsidenced. All right, I have to tease a little bit. It was not showing, it was not sinking down. It was not subsiding. It was stationary. It was firm. As the deck punching shear developed, this fracture developed. The fracture you saw in the longer image. The deck was going down, and you see this rotation right here. This is rotating down. As this deck here was all going down, the car deck area, I'm going to point arrows. Don't keep me confined in this box. It goes all the way over to the wall. That fracture is your beginning of your deck failure. Okay. So I believe that column's under here. The deck is creeping down. It's doing this. It has that fracture over there by that one column, and all of this is creeping down also. So this is, let's do some exaggeration like that. Okay, and that's that rotation outwards also, because this box is no longer square. To rotate down, considering nothing pushed it laterally. Like I said, a car backing into the railing, pushing the soil, and then pushing that over. We would see also this would break here, and what are the odds it would push at the bottom of the box and slide it over only at the top? It's possible. You know, as I state, anything is possible. You can tell me I can shrink down to 1 inch, and I'm not talking about, you know, my size. You can tell me I can shrink my entire body down to 1 inch. You could say I can't do it. I'm like, well, it's possible. You just have to give me the technology to do it. I'll tell you what I need, and you do it, and it's possible. Oh, if you don't have the technology, well, that's not my fault. I just said anything's possible. So if you keep your mind open, anything is possible. So you have to, you know, think outside the box about what could also do this. Truck, the soil, the pushing, trying to debunk yourself is what I'm driving at. Try to do it. Okay, so now this is where I believe we're getting at that lifting of the box here, that the columns underneath, as the deck flat goes left and right, this just gives us a larger gap here and a tighter gap here. Let's do an exaggeration. So let's do, well, let me try this. Do an exaggeration. And then, all right, so that didn't work. It's got to be more solid here. Definitely confusing you, right? Let's do this again. So let's see if I can just use this. Rotation down. All right, so this becomes so this is solid, right? But above it, it's an extension of the column because it's also solid. It's not going to do much there, deflection there. It's going to rotate. Thereupon is where it's going to do its 2 pivot points from the center line of the column thereabouts. My crows are here. I got some crows that holler at my window. And I feed them. I literally, I'm learning a lot about crows. I'll tell you about them. There are 4 crows, and crows are so beautiful. They're intelligent as hell. One thing, they don't shit on my car. The other one is, when they're hungry, they'll scream at my window. Then they know they have to be patient. They go around from my window to the front of the house, where I then find some food for them, bring it out to them, and I throw it out on the ground. Now, crows will not just go down there, all 4 of them at once. If there's one crow there, once he's made the food call, meaning literally he makes the food call not just to me but to his buddies, he'll get on the wire and scream. And guys, I want you to observe this yourself. You'll hear a crow squeaking, "Arr, arr, arr," right? Whatever tone he has. The other crows recognize it. And he'll do it. He will not go down there and get that food himself. He will scream until another bird comes and does, like a military operation, does overwatch. The other bird will take place on the line. And if the other two or three birds do not show up, two other birds do not show up, this is a 4. And they actually call a whole bunch of them a murder. Isn't that weird? But this one will do overwatch now. And this crow will go down land, even though he knows me. They're very intelligent. He will still be skeptical and on his tippy toes, ready to jet at just a flinch. So he's quite skeptical. You're not going to trap him. They're like a rat, but much more intelligent than that. So he'll do that. Now, this one will do the call outs, and then another one will come and do overwatch. And while he's doing overwatch, he can now go down, and this one sometimes will take off and let him grab a couple of pecks. They really don't grab. They're not greedy pigs. They won't stay down there long, and they'll come back. They won't make themselves, like most animals, take the same trail every day. They won't stay down there just gorging themselves. They'll grab something and move away. And this may be as little as 1 minute total time to, I don't know. I'd only give it 2 minutes. Sorry for this, seconds. I'd only give it 2 minutes. So they're very intelligent. I've got one now giving me the orders in the background. Now let's get back to this content. I'm just like breaking up the topic a little bit. This is interesting because it looks like a repair, right? And here's the column here. It looks like a repair. Why repair next to the wall? It stands out. Its coloration stands out. Is it a repair? Now back to the association. They called the expert. They didn't rely on themselves. They called an expert to get an opinion on this. The expert gave it a pass, that it was shrubbery, as I understand. To me, this is clearly a rotation. I don't see shrubs through there. I don't see these shrubs having the ability to do that on a block wall system and shove it this much forward. It wouldn't be the base moving at that point to shove this entire system with its load to shove it forward, to move it forward. I just don't have it doing that. And you guys could look up surcharge and you would understand what I mean. This would be root expansion, and these roots, I don't see them doing it. So back to this area here where the car area I said went down. I discussed this in other the images videos, and they're the 90s. Okay, I had to clear my throat. Sometimes you hear me clear my throat and I forget to press pause. I apologize if it offends you. You should try talking as much as I have to talk and not have to clear your throat. And I'll divert again the epiglottis as I'm talking. I can't swallow if I'm also exhaling my communication. The epiglottis gets moist with fluid. It drips down through surface tension. Surface tension is fluid related, and it can try to get into the airway. A cough is demanded to expel the moisture off the epiglottis. Okay, so here's our rebar, our engagement here. This is in video 9 I talk about. Video 9 or 10 I go into this again. Back here, right off this column, there's a fracture that I reveal in other videos. That's identifying that the deck is deflecting. The other part of that deck would be over there by the planter box. So we have on this end the cars. We're looking now, this fracture here, deflecting, and part of that indication of deflection is the core sample. And the core sample looks like, fractured in multiple places. We see the rebar through it. And I talked to you about in an entire video about deflection, how deflection, one of the first things that break, everybody says it's shear. I say negative. Negative meaning wrong. First thing that fails is the bond connection of the steel. And then you get what people identify as a shear fracture. First thing that fails is the bond between the concrete and the steel. This would be indicating of your core sample over here. This is not taught in schools. This is my theory, and I say it's solid. I'd like somebody to try to disprove me, besides just saying it's a shear fracture, there's shear fractures, and no, this happens first. This bond break happens first, as also indicated by this core sample that they removed here and at the other location in front of the number 111 structure condo, further out, where they did a core sample there by the column further back. That also indicates deflection. Remember, we have these offsets that are just wonky crazy. And here is my one of my models I did, trying to show you the planter box, how the planter box was level. This works with the near the sun, where he states that he believes there's 2 fractures. I believe that too. I believe when the building came down, it drove this BMA area down in one shot. I believe that this part of the deck came out first. Over to here. Came out first. This was first. And when the building went down, it drove this down flat, including the BMAs. So the when that other part of the structure came down, and I base that on, again, that this rebar, if you remember, I've said about a year ago that this rebar is already shown it has no ability to tug on jack shit, because it's not engaged enough. It's some engagement there, but it's not enough. It's probably, before you turn up, maybe 7 inches of engagement. Remember, this is those drop slab details, and right about here is the sample that's shit. I'm sorry, it would be further out. And then a deck turns up here because it put that lower planter blocks there. So it's shit way out to here. So that fracture I described, if they did another core sample besides here, they'd have went into the planter box, that lower planter box, and did another core sample, I would predict that they would see about the same fracture, no engagement with the rebar. That means what's left to engage, hold on the rest of this pad, 9.5 inches, let's call it. I think it's a little less than that. Is only the thickness of this and the cover that they left on there, so you deduct that. So it's only this engagement there. And it's not enough to pull down the rest of this structure. It would have to pull this, the shear links in here, the stirrups in here would have to also engage, pull, and then now pull on this part of the upper slab. And that's all being done with this lack of engagement here, and only 7 inches. I don't see that happening. So I think I'll end it with this video, this part of the video here. Remember, our planter box, this is the column that is lifting up in 2 directions. So this would be, let me say this is down and this side is up. Remember the drive, that this is not subsided. So I'm going to do up here. I'm going to put the fracture, okay, where am I? Fracture line here. I'm going to put a core sample that's crappy here. Going back to the diagonal over here somewhere. Let's see, planter box? No. So this is the planter box, I believe. So I'm doing a crappy core sample here. Let's see if I can change colors for you. Crappy, planter box, column. That's column in planter box. Fracture. There's a planter box here. All this walkway stays. Core sample with the fracture. Remember the fracture as I theorized, like that. So you're getting this failing first. That's why you're able to get that core sample to look that way. I say this is down, D-O-W-N. Let's do that. This is up. So this is up. This would be down over here. A rotation of our box. So we're going to extend it out a bit. Let's change colors. Well, looks wrong color. I got a blue up there already. Let's go with the red. I got some red too. So let's do this. This box is indicating is rotating down. Oh, look where that puts us. Right in our butterfly zone. This is this is the part that's rotating down. This direction also. You need look no further for vibration and load cycling than these cars. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3 being my primaries. Cycling this deck numerous times. This deck, I referred to it as a bridge deck because cars drive on it. Now it's a bridge deck with a caveat that it has a parking deck also. It's a parking deck, bridge deck. Below the cars, it's an overhang. It's got a history of an overhang, overpass for vehicles below. It has a history of falling debris, fractures, cracks, an overlay on top of it. The overlay, I did a video on that. That's so critical to extending the life of this deck, even though it wasn't bonded fully. I show that over here, this deck, the bond is capable of a cantilever effect, and as it is over top of each one of these columns over here out in this part of the deck, it creates its own critical shear zone and then a little bit of tributary zone. It creates its own. It showed itself here how it can cantilever off the side of a pool deck. That was pretty amazing because it's not on top of this. Actually, it goes over top, but it's not resting on there. And yet this deck is able to keep itself in an overhang position without fracturing. I talk about how if you then put it over top of all of these columns here, okay, so over top, these are over top. These are not over top. These are, because there's a column there, they just butted up to. So these are just butted. Okay, so this is my structure now. So this is just butted up to. So this becomes a dead load. Okay, so this becomes, well, this side, because that's an elevated side over here. It's like 1 foot something high. This is dead load. All right, this is all dead load decking here. The extra overlay. All of it. Planter box butts up to the planter box. All dead load. Okay, over here, it all of a sudden goes over top. Nope, there's a column that goes straight up to the top floor. So again, all dead load. There's a planter box here, so the deck goes up to it. The concrete's a dead load. All dead load. Back to here now, it becomes a over the top, but it has some critical shear zone ability and a cantilever effect out to it to a degree. So this one is butted up. There's a planter box, so it's butted up to. This is up to. Out here is different behaviors. Here, 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 here. And there's a construction joint somewhere about here. So if you look at this, you see that this is actually stronger here in all these areas. Again, we're back down to the butterfly in the middle. But critically so is this fracture right here. Critically so is the identifying of that fracture along that planter box there, the month of the failure. And it appears to me as the deflection goes away from this planter box, that direction. Now, if the planter box was 90 degrees, let's say, let me do this. Let me show you the planter box at 90 degrees. So here's the deck. We're going to look at it in this profile like this. And here's the planter box, right? So here's the planter box. This is 90 degrees. We're looking at the deck here. We're out here in this pool area, pool deck here, right? This is where we're looking. And that's 90 degrees. Can you get this to rotate the back side of the box to rotate towards this direction here? Can you get that and still get what you observe. Well, why would it fracture the front? I don't have that. We have to get that fracture going that long direction. I have that column, again, being rigid, transferring up into the, now I'm double dipping on the imagery. I have the column double dipping now. Let's see. So here it is, solid block above it. And then here's the fracture now. I'm double dipping on the design as I'm doing that. And our rotations are down these two directions. And we also have the failure in that direction because of the deck doing what? This offset, this huge offset. And right about here is where it should be. I mean, literally, they knew where it should be. They literally put the triangulation there, 6 foot in there. So they know, the engineer knew that's where it should be, but then he did this offset. And if you take it from here, it's 50 degrees. If you take it from here, it's a different degree. It's 14.6. If you take it from there, it's 50 degrees approximately. However you measure your offsets. Either way, they're out of bounds. All right, so that gives us this stressed area here. End the video. Hopefully this is helpful for you. You can watch it again. All right, so shout out to anyone who's questioning me. That's good. And again, this is the deck collapse first, and then we have the roof with like the shake table idea. The roof being weaker. You have to look at video 10 where I talk about, you can see the PSI, the concrete changes around the, at the 7th floor, I think, up, and also the rebar reduction goes way up, way down rather, meaning it's a lot less. Just 4 pieces of rebar on the C columns, the face, just four pieces all the way up to the roof with a reduction in PSI, which means your bond strength during shaking is going to be a lot weaker. Love you guys. Bye.